In the last video, I showed you how to interact with the four-color problem and spirals. In this video, I'm going to show you how spirals can nest in each other. Here on Wolfram Alpha, I'm showing how Pythagorean triples relate to the metallic mean ratios. So this one decays by 1/2. Here the decay is 1/3. Now a 1/4 decay. And as you can see, the parent rectangle's ratio, as we increment here, goes 1 to 2, 1 to 3, 1 to 4. Now it's going 1 to 5. And I'm going to stop here at 1 to 6. So the parent is 1 to 6, and the decay is 1/6. Here I show the metallic mean way of looking at it for the 1 to 2 ratio, 1/2 decay, which is also the 3, 4, 5 triangle. Because the ratio for the parent rectangle is 1 to 2, I'm going to construct this recursion as the base unit for the silver metallic mean rectangle. We'll get to that later. So here I'm putting some arrows into the rectangle so you can see how the spin turns the arrows. And the decay here is fairly simple, but I'll also do the 4-color problem. Now with this simple decay, all I have to do is divide by 2. 4, 8. So the 3, 4, 5 Pythagorean triple triangle, when presented in this metallic mean way, is the geometric series. So this is harkening back to the last video where I showed how to do the 4-color problem. In spiral form. Now I could do this to different powers, but since I know the geometric series by heart, I just put in the total values. I could repeat this forever, but I'll just do one more, all the way up to 256 already. Alright, now we have the 1/2 base for the silver ratio. course, the 1 by 2 is represented as 4 by 8, but that reduces. So the formula has height first with second. Inkscape has it the other way around. We put 8 in and 4 in, and come up with the metallic mean ratio. X is either -1 minus square root of 2 or square root of 2 minus 1. So the negative x is -2.41421, etc., which absolute is the same as the silver ratio, according to Wikipedia. Again, just double checking. Now taking those ratios and putting them into Inkscape. Here, I'm using the negative value, the absolute version of it, to, instead of decay, to grow, to expand. Now there are very interesting implications for the golden ratio, because unlike these other metallic means that have 1 to 2, 1 to 3, 1 to 4, etc. ratios, the golden ratio is a 1-to-1 ratio, which is not possible to create a recursive base with, since an a squared plus b squared equals c squared, the Pythagorean theorem, b plus c is always greater than a unless b is 0. So the golden ratio is unique compared to all the rest of these, in that it can't have a recursive base. It can only have a finite base. So finishing up the silver ratio pattern here. Now I decide to decay. Thank you for watching this video. If you're interested in supporting, check out my merch and leave some comments about how maybe I can improve the merch. Have a good one.